Hello, dear students. Welcome to the world of physics. Today, we are going to learn about some fascinating wonders of physics. Have you ever heard the term inertia? Are you all familiar with the term inertia? So today, we are going to learn about inertia and its types. Let's have a look at this picture. What do you observe in this picture? Yes, you are right. A man is trying to push a heavy rock. Is he able to change the state of the rock? No, he is not able to change the state of the rock. He is trying hard to move the rock, but the object is showing a tendency to remain at the state of rest. Let's have a look at another example. Look at this picture. A book is placed in a table. What is the state of the book here? Yes, the book is at the state of rest. Whether the book can change its state by itself? Yes, you are right. The book cannot change its state by itself. The book is showing a tendency to remain at the state of rest. You all are familiar with this instance, right? When we shake a tree, the state of the tree changes, whereas the state of the fruit remains the same. The fruit remains at its state of rest, and that's why the fruit falls down when it is shaken. Let's have a look at a day-to-day example. When a bus starts moving, which is at rest, the passengers move backwards. What may be the reason behind it? Yes, what you said is right. When the bus suddenly starts, the bus will change its state to motion, whereas the passengers have a tendency to remain at the state of rest. That's why when a bus suddenly starts moving, the passengers move backwards. Let's have a look at this picture. In this picture, you can see a glass, a cardboard, and a coin. The coin is placed above the cardboard and a glass is placed under that. What will happen when the cardboard is flipped? Can you guess? Let's see what happens. See, when the cardboard is flipped, the coin drops into the glass. What is the reason behind it? Yes, the coin remains at its state of rest. That's why the coin falls inside the glass, whereas the cardboard move away. Is the concept clear for you? Let's have a look at another example. See the picture? In the picture, you can see that the dust particles is separated from a mat. In the picture, it is obvious that the mat changes its state, whereas the dust particles present in the mat remains at the state of rest. The dust particles in the mat show a tendency to remain at its state of rest. So, in all these examples, you have seen that a body at rest has a tendency to remain at its state of rest. Or you can say that a body at rest has an inability to change its state by itself. What is this called it is called the inertia of rest. So what do you mean by inertia of rest? Yes, the tendency of a body to remain at rest or its inability to change its state of rest by itself is known as the inertia of rest. In all the examples that we come across, we have seen that the body at rest shows a tendency to remain at its state of rest, or it shows an inability to change its state. So it is due to the inertia of rest. So we have learned about inertia of rest. Is this inertia only applicable for bodies at rest? Let's explore more to this concept. Are you ready for that? Look at this picture. A bus in motion suddenly brakes. When a bus in motion suddenly brakes, what happens to the passengers? Yes, when a moving bus suddenly brakes, the passengers in the bus move forward. Have you ever wondered what may be the reason behind it? Here, the bus is in motion. So, the passengers in the bus will be also in motion. When the bus suddenly brakes, the passenger will have a tendency to remain at the state of motion, or the passenger will have an inability to change his state of motion. This is the reason why a passenger moves forward when a moving bus suddenly brakes. Let's have a look at more examples. See, in this picture, a ball is rolling down. Whether the ball will stop rolling itself? No, the body or the ball will remain rolling unless it is influenced by friction or any other external force. So here also a body at motion is showing a tendency to remain at its state of motion. Have you ever seen an athlete meet? Very good. Here, an athlete moving at full speed continue moving forward even after crossing the finishing line. What may be the reason behind it? Yes, the athlete's body is at the state of motion. So, even after crossing the finishing line, the athlete's body show a tendency to remain at the state of motion. That is why an athlete is not able to stop running even after the crossing line is passed. So, in all these examples, we have seen that a body at motion has a tendency to remain at its state of motion. What is this called? Yes, this is called inertia of motion. So let's look at the definition of inertia of motion. Inertia of motion is the tendency of an object in motion to resist any change to its state of uniform motion. So, today we have learned about inertia of rest and inertia of motion. Let's have a comparison between both. Have a look at this tabular column. Inertia of rest is the tendency of a body to remain at the state of rest or its inability to change its state of rest by itself. Whereas inertia of motion is the tendency of an object in motion to resist any change to its state of uniform motion. So I hope that the concept of inertia of rest and inertia of motion is clear for you. Let's have a follow-up activity. Your follow-up activity is list out more examples of inertia of rest and motion from your daily life. I hope that you all understand this concept clearly. We'll see you in the next class. Thank you.